Since the dawn of humanity, humans have observed that large migratory birds fly in a V formation. However, the reason why they fly in this formation has eluded us. Recent studies shed light into this phenomenon, and in this animation, we will explain why migratory birds fly in the V formation. The first thing you should understand is that air always flows from high to low pressure regions, and this is the reason why we have wind in the first place. The second thing we need to understand is that winged flight requires low pressure above the wings and high pressure below the wings. This difference in pressure creates a lift, and it's that lift that keeps birds and airplanes in the air. So now that we know this information, what does this have to do with birds flying in a V formation? Actually, it's those exact reasons birds fly in the V formation. When a bird pushes its wings downwards, it creates a strong low pressure region above the wings and high pressure under the wings. It's the strong high pressure under the wings that forces the air to flow low pressure air above the wings. Since the birds are moving forward, this flow of air is mostly observed at the tip of the wings, as shown in this animation with the red arrows during the downstroke. In the upstroke, this phenomenon is not as strong, because the feathers create gaps to let the air escape from the top of the wing to the bottom, as described in the video link here. However, the downstroke motion of the wings creates a very strong airflow in the direction of the red arrows. Since birds fly forward in the direction of the large white arrows, this airflow creates what is called a wingtip vortices. In this video, these vortices are shown as cone-shaped figures extending from the tip of the wing in the opposite direction of the flight. These vortices are very persistent and extend along the flight path as long streaks. As you can see, they are rotating in the opposite directions. While the right wing vortex rotates in the counterclockwise direction, the left wing vortex rotates in the clockwise direction. These air rotations induce airflow patterns around the surrounding air. Let's see this airflow with the header bird HB, and for the first bird on the right, RB1. As you can see, there is an updraft at the outer edges of the wings and a downdraft between the wing tips. Actually, the downdraft is more pronounced due to the combined effects of the two wings. To a bird flying just behind another bird would not be a good place to fly, because the strong downdraft would push the bird down. Commercial flights have been in accidents because of this phenomenon explained here. As you can see, the good spots for a bird following another bird are the regions where the upward drafts, so the bird can be pushed up. This spot happens to be on the right and left sides, just behind the bird in the lead, HB. So what's the best spot to fly for bird RB2, which is behind bird RB1? You may think that the left and right spots behind RB1 are the best. However, that is not the case. The only good spot for RB2 is the right side behind RB1. The left side of RB1 has an updraft region, but it also has a downdraft due to the lead bird HB. The two opposite effects created by HB and RB1 diminish each other's movements and creates choppy airflow in that region. The same thing can be said for LB2 following bird LB1. Now let's turn on the air motion arrows for all of the birds in this animation. Notice that inside the cone-shaped region of the V formation, air moves mostly downward, and there's also a region with an upward draft tendency. The airflow in that region is not predictable and choppy. Any bird flying in that area would be pushed downward. The best spot to fly is in the boundary of the V-shaped region, where there are constant updrafts. The birds flying in the V formation benefit from the updraft created by the bird just in front of it. In this formation, only the head bird will spend more energy than the rest of the birds in this formation. The others will reduce their power consumption 10 to 20%. If a bird flies away from the V formation, its power consumption will be just as much as the head bird. We hope that you enjoyed this tutorial. Please take a moment to like our videos and to subscribe to our channel.